after you open up the transmission, you can see the valve body sticking out the bottom. Now to get to the forks, we're going to take the valve body out. This is the orientation it comes out. You can see the pistons line up with each individual fork. Now each of these forks controls two separate gears, just like a normal manual transmission. This top one, that's 6th gear. This one below it is 4th and 2nd. This one is 1st and reverse. And then this one down here, which is not aluminum, this goes into the back housing, and that controls 3rd and 5th. Okay, now that we have the valve body out and we've talked about the forks, we can explore the fluid path through the transmission. Now you can see here, the filter, the sump filter hooks into here, and this is where the fluid begins its journey. The pump's in here with the valve body, or the clutch valve body, which is in the front case. We're going to talk about the main valve body today. So after the pump has made pressure, it sends it back through these 3 ports that in turn go into the valve body. The larger port is the main line pressure line, and this helps to control the entire valve body, this one and the clutch valve body. These 2 smaller ports are known as the access pressures or clutch pressures, and they go to these 2 solenoids right here and here, and the 2 clutch solenoids in the clutch valve body, and they help to control shifting and clutch release and clutch pressure. Okay, now when we look at the valve body, we see these pistons that can move, and we correspond them to the forks before. Now each of these pistons controls 2 gears, just like the forks, except 6th gear, because there's only 6 gears and a reverse. Now you see these big black boxes. There's one on top of here, there's one tucked back here, here, and here. Now these help to track the position of these, so the computer knows where the piston is in relation to the fork, and where the fork is in the gear. So you know if you're actually engaged in a gear, or you're in neutral, or you're engaged in the other gear. And the way it does this, these track the movement of the magnets inside, and there's a magnet in whichever corresponding end the sensor is. So you can see this one has magnets on both ends, and that tells us that it's the first reverse piston, because first and reverse has a safety switch where you can't mistake first and reverse very easily, because it has one sensor here and one sensor here. Therefore it needs 2 magnets. All the other ones have only 1 magnet and 1 sensor per piston. Now if we take off this black plastic, this has all the leads for all the solenoids. And we can look at all the solenoids now, and you can see there's 4 solenoids in a row, and then this solenoid up here, they have different operations. Now each of these 4 solenoids dictate the fluid path behind the pistons to tell each piston to either move right or left. And since there's only 4 and we have 8 different chambers, that's the job of this solenoid. This solenoid changes the job of these 4, so that we can use 4 solenoids to move 8 different chambers, since each piston has 2 chambers. So think of it as these 4 solenoids are in charge of these 4 chambers, and then in order to be in charge of these 4 chambers, this solenoid switches, and now these 4 have a different job, and they control these 4. Now when the pressure comes in through the line, it first meets a sensor, the pressure sensor, and this is the one you see on the dash. You can track in the car, and we'll look at that later. And now after that, the fluid is distributed to all 5 of these solenoids, and it hits this one first, so it can decide which 4 of these do what. And after that, there's some springs and retainers inside to dictate pressure to these 2. And these 2, the access solenoids, are in charge of both clutch A and clutch B, and access A and access B respectively, and they dictate the shifts. So once these are set up the correct way to move a piston, these actually allow the fluid to move the piston. So these don't actually help move the piston at all. They just direct the fluid where it should go, and these two pulse the fluid and block off the path so that the fluid backs up and then is forced to enter one of these chambers and actually shift gears. And these solenoids also dictate clutch pressure. The pressure from the line goes to these solenoids first and then to clutch A and B. So a low clutch pressure could also be one of these solenoids, because these solenoids dictate the pressure going to clutch A and clutch B. One of the things Nissan had to start doing with their transmissions was adding these TSB clips. I'm sure you've heard of them. They're a really popular thing to do on an older transmission, and they come on the newer ones. Nissan made these a little bit too narrow, so you can see right here there's a bunch of wear, and what happens is these pistons, they move back and forth, but they also can rotate, and they start rotating on the fork, and you wouldn't think this would be an issue, but remember these magnets we talked about? If they're twisted, they no longer are right next to the sensor, so they can't read correctly, and the the TCU has no idea where this piston is. It doesn't know if it's in a gear, in neutral, in the other gear, and that's when you start having bad things happen. So Nissan came out with this, and it's just a simple snap on like that, and then that adds just enough clearance to where this can't rotate in the fork, and then all those problems are fixed.
So we are currently in park. We're going to go ahead and shift into reverse gear, and when I shift into reverse, you're going to see these two voltages change. That's because we are moving the 1R piston, which is moving the first reverse shift fork and the first reverse shifting sleeve. Now the sleeve is going to engage reverse gear, so we're going to see one sensor show a voltage that's lower as the piston is moving away from it, and the other sensor show a voltage that's higher because that sensor is actually getting closer to the magnet on the piston as the piston moves over. So let's go into reverse gear. You can see we're engaged in reverse because this position sensor shows, well, 1.4 volts, but it's close enough. And position sensor number 2 shows 4 volts. So basically the piston, where these two sensors are reading from, has moved, so the magnet has gotten closer to this sensor and further away from this sensor. So that's reverse gear. If we go back into neutral, we can see we're back at 2.5 volts again, and everything's in the neutral position. Now we move over to first gear. In first gear, we can see a lot has moved, but this has moved in another direction. Remember, when we were in reverse gear, this one went to a lower voltage. It's higher now because before, when we went into reverse gear, the piston moved away from this sensor to engage reverse, but to engage first gear, we got to go the opposite direction. So we went to neutral, which was halfway in between, and now we're in first gear, which brings the magnet on the piston closest to the sensor. So this sensor reads a voltage of close to 4 volts, which means it's fully engaged, and this sensor reads 1.3 volts, which means that it's fully, the piston has moved away from that sensor. And another thing we can see here too is second gear has been pre-selected. So remember, in neutral, everything was at 2.5 volts. So when we go into drive, we're engaging first gear, but it's pre-selecting second gear at the same time. So, you know, in DCT true form here, we have, you know, 2 gears essentially engaged at the same time. So first gear is now engaged. We're going to accelerate in first gear. As we accelerate, you see things are going to move up and down a little bit because things are moving around in the transmission, but it still has second gear engaged. Now when we're in normal mode, so this switch here on the side, if we're in the neutral position, not R, but normal, if we're in that position, then the gear that is engaged in the transmission, the TCM is going to pre-select the next highest gear. So right now we're in first gear, second gear is also pre-selected. We engage second gear. You can see the 1R position sensors are now back in the neutral position. Second gear is still engaged, but now a pre-selected third gear. Third gear, we're now down to 1.3 volts. So if we accelerate a little bit more, ABS is clicking on. We accelerate a little bit more and now shift into third gear. You can see third gear is still selected, but now a pre-selected fourth gear. Now remember, we have a piston here that does 2 gears, so it can select both second and fourth gear. So before when we were in second gear, this showed a low voltage because the piston was engaged for second gear all the way into one position. And now that we're in fourth gear, the piston has moved all the way over into the other direction. So now the magnet is actually closer to the sensor, where before it was further away. So let's downshift from third gear back into second again. So now that we're in second, you can see the voltage is low again because we have second gear engaged. So the magnet and piston is actually furthest away from the sensor. We engage third, and now it went from second to fourth. So the way this works is, so when we're in second gear, it's actually using second gear right now. And we can see the voltage has dropped. We engage third gear. Third gear is now engaged, which nothing has changed on that end, but this end, fourth gear is pre-selected. You can see how the voltage has changed there. Second gear, third gear stays the same, fourth gear changes.